Okay, so welcome to the first lesson of engineering thermodynamics. So usually the first part of thermodynamics when you're studying it is very conceptual. There's a lot of important terms to familiarize yourself with to be able to solve the numerical problems later with much more confidence. So the first concept is the concept of a system. Now, what is a system? A system is whatever we want to study. It could be anything you want. I know it sounds crazy, but it could be anything you want it to be, whatever we want to study. And then, so let's say we have a cup of coffee. Right? Then the cup of coffee is in a room where the temperature is 20 degrees. The arrows indicate the flow of air. And then your coffee is at 70 degrees Celsius. So let's say we want our system to be the coffee itself, meaning that the liquid inside of here, that's our system. And then the environment, whatever else that's not the system, we call that our surroundings. So that's very intuitive right here. Surroundings is everything outside the system. Okay, try to write a little faster. So we have the system, we have the surroundings, and whatever separates it, we call that the boundary. So this, I don't know if you could see it, this dashed line here, just outside of the coffee, kind of, you can picture that as the rim of the coffee cup, or the edges. So that's going to be your boundary. And it's what separates the system and its surroundings. And that's usually an area of interest. The boundary. It's where energy flows. What is energy? Energy is defined as anything that can cause change. Anything that has the ability to cause change. In the thermodynamics course, your energy is typically found in two forms. It can either be heat. Energy could move in a form of heat. So that's applicable to our coffee example. Or it could be in the form of work. And that could be, the classic example would be heating up a piston. Right. And then you would have boundary work here where the piston expands its volume. So that's usually notated as WB. We'll get to that later. So that's the concept of a system. Usually in thermodynamics, I'll stop saying usually as much. You have open systems and you have closed systems. Let's get a little bit more space here. All right. So closed systems, let's start with that. Closed systems are usually known as control mass systems, meaning that we have an idea about the mass, the quantity of mass in that system. The mass quantity does not change, and that could be broken into two further categories. You could have an isolated system, or you could have a system with boundaries. This could have boundaries as well, but for an isolated system, it's a system where energy cannot cross. Energy cannot cross its boundaries. So there's no way energy would flow in the form of work or heat. That could be like an insulated mug. The kind of mug that coffee addicts would use all the time. And that helps with maintaining that coffee temperature throughout the day. So because it's insulated, there's no energy flowing between through the boundaries of that system. So you get to keep that coffee for hotter. You get to keep it the coffee at that temperature for a way longer time. The coffee won't cool off, basically. That's an example. An example of that would be an insulated mug. You could have a system with fixed boundaries where energy does cross, unlike an isolated system. Or you could have a system with moving boundaries, or moving boundary. Let's get used to calling them a boundary. So an example of that would be cooking for fixed boundaries. Cooking meat. You are changing the temperature of the meat. You're adding heat into it. You're cooking the meat, but the boundaries of the meat, say that this is our meat. The boundaries stay the same. They don't change. The meat does not expand, nor does it shrink when you're cooking it. It's usually the same dimensions. So that's an example of fixed boundaries in an approximated way to say that the boundaries do not change when you're cooking. Moving boundaries, that same example here from the piston. So the piston would have moving boundaries. You could end up heating air. Let's say we have air inside of here, and heating up that air, the air molecules would eventually expand, and the boundaries of that system, like assume the boundaries the boundary thus would move and expand, creating a bigger system. So that's what we call moving boundary. That's an example of a moving boundary system. So this is it for the closed systems. You can have an isolated system where energy cannot cross the boundary, like an insulated mug. But otherwise, you could have a fixed boundary where energy does cross, such as the cup of coffee being cooled off. Eventually, all that heat is going to be lost to the environment. You could have moving boundaries where the piston heats up, or the air inside the piston heats up, inducing a movement of the top layer of the piston, and you would have bigger system to play with or to analyze. So for open systems, this is where you have mass flow. Mass flowing in and out, usually notated with an m dot. We'll get to that later. Also known as control volume. So this is kind of similar to this category right here for the open volume. You're going to have fixed boundary, meaning that the volume stays constant. So you're going to have mass flow in and out. But whatever we consider to be our control volume, that region is going to be the same throughout our analysis. So an example of that would be, say, an air conditioner. Air conditioner usually has air flowing in, hot air, and then air flowing out, the cold air being pumped out after the hot air goes in and then loses all the heat to the refrigerant inside the air conditioner. So let's say this is our control volume right here. As you can see, that region of space will never change, and you're going to have an inlet and an outlet. And this is known as the fixed boundary control volume analysis. You could have variable boundary, or moving boundary again. And this is, say, let's use that piston again right here. This is when you have that same piston but say now you have a mass in, mass flowing in, and then you have a mass out. But you're also heating that piston. So let's say the mass flows in at a rate of 10 kilograms per second, and it goes out at a rate of 5 kilograms per second. So that's your mass in, and then that's your mass out, and then you're also heating the system. So the boundary of the system is changing, similar to that situation from earlier for the moving boundary here for the control mass. So in this case, this is a complicated system, and this is a system that we will not be considering for this course usually. So our analysis for this course is mainly going to involve control mass systems where we have either an isolated case, fixed boundary case, a moving boundary case, or for the control volume where we do have mass flow, we're only going to consider fixed boundary control volumes. So usually the moving boundaries are a little bit more complicated. I don't think that we're going to be running into them for now. And that concludes the introductory session for thermodynamics. Thank you.